a 2.25 centimeter diameter hose, 2.25 centimeter diameter hose, fills a 25-liter bucket in 1.5 minutes. A 3/4 centimeter diameter nozzle is attached to the hose, and the hose is held 1.25 meters above the ground, projecting water horizontally. How far is water projected horizontally from the nozzle base? Okay. So let me sketch the hose without the nozzle first. So here's the hose, and it has input area A1, output area A1, input velocity of water V1, output velocity of water same, and Q is equal to A1 times V1, which is equal to the volume of the bucket, 25 liters. A liter is 10 to the third cubic centimeters. And that fills in 90 seconds. That's 1.5 minutes. And I want to put everything into cubic meters, so I'm going to multiply by cubic meters over cubic centimeters. There are 10 to the 6th cubic centimeters in 1 meter. That's my conversion factor. And that gives me a Q of 2.78 times 10 to the minus 4 cubic meters per second. Okay, so if we put a nozzle on the end of the hose, still has input area A1 and velocity V1, but now we're going to attach the nozzle like this, and I've got a smaller area A2, which means I've got a bigger exit velocity. And I'm going to have the same Q here. I have the same water coming in per unit time, so I have to have the same water coming out per unit time. That's the equation of continuity. And so I know that A2 V2 is also going to be equal to Q. And that allows me to figure out what V2 is. V2 is going to be Q over A2. Q is this number right here, and so A2 is going to be pi over 4 times the diameter, 0.75 centimeters. That's 0.75 times 10 to the minus 2 meters squared, keeping everything in meters here, and that comes out to be 4.42 times 10 to the minus 5 square meters. So then V2 is equal to 2.78 times 10 to the minus 4 cubic meters per second divided by 4.42 times 10 to the minus 5 square meters. Quick check on dimensions, should be meters per second, and I see that it is meters squared divided by into meters cubed gives me meters, and so that computes out to be 6.29 meters per second. Okay, so now I know that the hose, here's the hose, comes out of the nozzle like this, and the nozzle is a certain distance from the ground, so the ground is down here, and it's going to come out initially horizontally and then come down like this, and the initial horizontal velocity is the V2 that I computed above, and if the hose nozzle is the distance h above the ground, I'm going to first of all compute the fall time, which is going to be given by h is equal to 1/2 gt squared, which means that t is equal to 2h over g square root 2 times 1.25 meters divided by 10 meters per second using an easy number for g, and that computes out to be half a second. And so this range here how far it goes from the horizontally from the base of the nozzle is simply going to be V2 times the fall time. There's no acceleration in the horizontal direction, ignoring air resistance. And so that's going to be equal to 6.29 meters per second times 0.5 seconds, which is 3.15, pretty close, meters.